Hey again, guys. Here is another example of ABC, but this time it's going to be one where we're not going to be able to do it by hand, okay? So suppose we have a couple of curves, something a little more complicated. How about 1 over, or x over square root of x squared plus 1, and how about x to the fourth minus x? All right, so first things first, I don't even know what these things look like, so let's get our calculators out and try to do it by hand. Okay? I mean with the calculator. So let's get them in there. Let's see. So x over square root of x squared plus 1. That takes care of the radical. That takes care of the fraction. And then x to the fourth minus x. And I'm not sure where these hit, so I'll just do a standard window first, zoom 6, and then I'll zoom in as necessary. So here comes y1, which was my square root 1. And then here comes the x to the... Okay, so it's definitely happening all around here. So it's pretty tight to the origin here. So let's go, -1 to, say, 3, and -1 to 3, and see what that does. Oops. I just realized I screwed up the scaling. Hang on. -1 to 3. Let's try that. Much gooder. Alright, so there's the square rooty one. There's the x to the fourth one. Okay, so my top curve is my first curve, so that's my y1. My y2 was my sort of, not parabola, but the quartic or whatever it is. So from here to here, it looks like it's the origin, but we can make sure to some point, which I have absolutely no idea where that is. So first things first, I know how to set this up because I know which one's on top and which one's on the bottom. So the top one, let's call this y1, and let's call this y2. So the top one is y1, and that's y2, and it's with respect to x. Because I labeled them 1 and 2, I can actually put that in here. So I'm thinking like AP exam, as long as they're labeled that way, you can put them into your setup that way. Especially if you're using the calculator, that definitely makes it easier to remember, what you're typing in. But we do need this point, so I'm pretty sure it starts at 0, but let's be 100% sure. Although that's silly, we know it's 0, right? Plug in 0, you get 0. Plug in 0, you get 0. It's definitely 0. This one's not so easy. So I'm going to find the intersection point. First curve, second curve, guess. And let's see. All right, 1.1808, but I only need 3 places, so I'll just go 1. Okay, so 1.181. Now here's a little trick. Since we are using the calculator to do this, a little trick is I want this x value to be able to use later for my integral, but I don't want to have to remember a lot of decimal places. So what you can do is if you quit right out of that and you take your x value, you can store... you can't see my buttons. Hold on. Hang on here. I can do a little better. Hang on. Let's try that again. Okay, x... Well, obviously I got from there, but then the store button is right here. I'm going to store the latest x value into some other letter. So I'll call it like alpha and then a. So alpha A is all the green stuff. And basically it's going to take that x value and store it into a. Alright, so this is the actual value. So now you may say, well, why can't I just do 1.18 or whatever? Well, you probably could, but I'm thinking AP exam, and I'm thinking I want it to be as accurate as possible so they don't, so I don't risk losing that answer point because I know how, they need to have it at least 3 places. So sometimes when you round too early, even if you do it properly, you might still get messed up later on. So I play it safe. I like to store the value. So that's A. So A is 1.180775703, just so we have it on paper. And basically I can rewrite this as from 0 to A, y1 minus y2 dx. And that would be full credit on the AP exam because I've already labeled everything. All right, but now we actually need to figure it out. So let the calculator do it. So this is going to be a math 9, I believe. That's your integral. Now those of you with the fancy calculators, remember you're just typing in exactly how it looks. It's probably going to have a value here and a value here. It's going to tell you to put something in here, maybe with respect to x, somewhere in there. It's the same exact idea. So I need to do y1 minus y2. Oops, minus y2. I said it, but I didn't type it. Right? Comma x, comma, I need to go from 0 to a. And that will literally give me everything I need. So 0.785 would be full credit. All right, worst case scenario, you could type in your functions here and here. Let's be a little annoying on this screen to do it, especially with the weird square root thing. And even the 0, like let's say that was another weird number. That could have been A and this could have been B, right? You just, you can store it however you want. I mean, literally, here, watch. What if I don't do A? What if I do 1.181? Let's see what we get different. So how many, look how many decimal places it's basically the same. Right, all the way up to like 7 decimal places is where it starts to switch. So it's not that big a deal. I don't know. I just like doing it because I like being accurate. Maybe my OCD kicks in. I don't know. But that's how you do it with the calculator. So get a good picture. Figure out your boundaries. Right, we're finding the area of the region in between these curves, the area between the curves. Find your boundaries, top minus bottom from A to B. That's it. Okay.